We got another circuit here. Thanks again to the people at FET. We have another circuit here, the same sort of circuit we had in the capacitor video. Same 9-volt battery, same two 10-ohm resistors, same 3 switches. The difference is our star, the inductor now. The inductor instead of the capacitor. Let's see how it's the same, but really let's see how it's different. What is an inductor? An inductor provides an EMF, a back EMF that fights against changes in current. Again, a capacitor, you could say, has an inertia, fights against changes in voltage. Here's the equation. Back EMF equals negative L di dt. Good luck. We've done this before. Same first 2 switches down, same simple series circuit. Same plan to measure current with an ammeter, to measure voltage with a voltmeter. Let's get to the videotape. Close switch 1 and close switch 2. Same situation here. We're measuring good current here right now. Remember what happened when we closed the middle switch with the capacitor? The current in that left-hand arm went to 0. This time we're going to close it. Wow, look at the voltmeter went to negative 4.5, but the current didn't change. Now the voltage across the inductor is slowly decreasing, and the current in the left-hand branch is slowly decreasing also. So what's happening here? Originally, when you close the switch, Nobody wanted to go through the inductor. It's too big a back EMF. You have a change in current, and that back EMF was fighting against you. But now slowly we have charge going through the inductor. We have a constant current through the inductor. No back EMF. No back EMF. That light bulb on the right sure is doing good, and we have no current at all through the branch on the left. No current, so we can throw that switch open or close. Doesn't make a difference there. All right, again, the inductor is fighting against changes in EMF. So what happens here? What happens here? Boom! Well, all the way up to 9. The voltmeter went all the way up to 9. Current is flowing the opposite direction. You see it. You threw that switch. You thought you were going to cut the current down to 0. You didn't, because the inductor is fighting against changes in current. So you tried to throw that current to 0, a big negative di dt, and the inductor had a back EMF to say something about that. So a completely different situation than we had with the capacitor, and the current is now going to 0.